So that's why we had the second one. These two, if I'm going to have a point discontinuity, they should match up, but it's going to be an open circle. So those two should also be equal to each other. So 7 is going to equal 2a plus 3b. And I just lined them up so that it'd be easy to work with. Now I can solve it. This is a system of equations. I have 2 equations and 2 things I don't know. Does anybody know and remember how we do this?
So the first one for A.
You can do that. There's nothing wrong with that. You can solve that first equation or second equation or any of them for any letter you want to and substitute in for the other one. My only drawback about doing that would be you'd have a lot of fractions to work with. There's nothing wrong with that. It's just a lot of places you can make a mistake. But, yes, that works. I'm glad you remembered that. Anybody think of another way we can solve it other than substitution? I really think this way is not taught as much. Elimination. Meaning I can take either the top or the bottom equation and multiply, as long as I multiply the whole thing through by -1. Then what happens when I add? What would cancel? Let's try it. Say I multiply the top one by -1. And it's okay as long as I multiply the whole thing by -1. That's not changing anything other than the way it looks. Yes. So it's positive 3 equals positive 3a minus 3b. And the one below it, I'm just going to rewrite. So what happens now when I add these? Yeah, the 3b's cancel out. So this is called the elimination, or sometimes it's also called the addition method, because what you're doing is you're adding things out. So I couldn't add them up the way they were because nothing would cancel out. But I knew these two were exactly the same. So if I just changed the sign of one of them, then they would cancel out. But you just got to remember to change the sign, you have to multiply everything through by that. So when I add these, I get 10 equals 5a. Divide by 5. A is 2. To find b, I plug it back into any equation. It can be the one you changed. It can be the ones you started with. You pick. Doesn't matter. Which equation you want to use? Okay. 7 equals 2 times a, which is now 2. Plus 3b. So 7 equals 4 plus 3b. Subtract 4 and divide by 3. There are my 2 answers, my A and B, that will cause a point discontinuity. The 2 equations will come together, but it'll be an open circle because there's no less than or greater than or equal to. Questions? That's as hard as it gets.
Will there be one like that?
Probably. If not, the multiple choice part on Thursday, then the free response part on Friday, or it could be on both. Okay, now let's go back and look at 1 and 2. It's the same as we've already done kind of things, but it's good practice. Okay, we're trying to figure out where there could be jump or point discontinuities. So I look at these numbers. They're both -1, so that's where my possible issue is. So I'm going to separate it like this. As x approaches -1 from the left, g of x approaches which equation? Yeah, the top one, because that's less than -1. So -1 plus 4 squared plus 3 plus -6. Okay, so the next one, as x approaches -1 from the right, what does g of x approach? The absolute value one, the second one, because that's where it's greater than -1. So absolute value of x, which is -1, minus 3, minus 10. So it's absolute value of -4 minus 10, which is -6. So they're the same. What's the one more thing I have to find? They are equal. Then one more thing.
Like the g of -1?
Yes. Is g of -1 defined? No. None of those have a less than or equal to or greater than or equal to. So since it's undefined, it can't be continuous. But it does have what kind of discontinuity? Point. Why is it point?
Because they equal the same.
Yes, because those two match up. Which is what we just did on the last problem. We made the two match up so we could have a point discontinuity. So we would say since both pieces approach the same y value and g of -1 is undefined, then g of x has a point discontinuity at x equals -1. Okay, so for the next one, we're looking for discontinuities. At what value could we have a discontinuity at? Yes, -1, because that's where the two both have the same x value. So we say as x approaches -1 from the left, g of x approaches the top equation. Sorry, I'm trying to squeeze this in. -1 plus 3 is 2 times -2, so -4 plus 2, that should be -2. And the next part is x approaches -1 from the right. G of x approaches the second equation. So the absolute value of -1 plus 3 minus 4. That's also -2. Do we have a value for g of -1? Yes. What is it? It's -2. It's this one, because that's where it's greater than or equal to. So what does that tell us? It's continuous. So g of x is continuous at x equals -1 because g of -1 equals -2 and both parts approach the same y value, which is -2. We've had one of each. So now, hopefully, you can finish your homework if you haven't already. And then tomorrow we can answer any questions. And then now my reviews, we've done everything. Everything throughout this is a review, but I will kind of, say, look at this. But anything that we've covered can be on there. Yes, ma'am.
For the day 9 homework, are both the previous classes part of it?
Are both they technically are, yes.
Okay.
Yes. Now, you don't have to have that turned in, but you might want to look at them, make sure you know how to do them before the test.